Hi guys, so today we're looking at chapter 15, integral calculus. So our learning outcome for today is to understand what an antiderivative is and find the antiderivative of a function. So the antiderivative of a function is simply the process of undoing the differentiation. So essentially, this is when the question gives you the derivative and you have to work backwards in order to find the function. Let's look at an example question. Differentiate 1/3 x to the power of 3 and hence find the antiderivatives of x squared. Okay, so we're given the function 1/3 x to the power of 3. The differential of this function, f prime x, becomes x squared. This means that the antiderivatives of x squared is in the form 1/3 x to the power of 3 plus c, where c is simply any constant. Let's have a look at why we put in the c. Okay, so we have our function f of x is equal to 1/3 x to the power of 3. Let's say that our function originally read 1/3 x to the power of 3 plus 5. When I derive this function, I get 3/3 x squared, and our constant goes to 0. Simplifying this, we get our derivative as x squared. I have my derivative, and I want to find my antiderivative. This means I want to undo the process of differentiation. I am given the derivative of x squared, and I want to work backwards to see what the original function is. In this case, my antiderivative of x squared would become 1/3 x to the power of 3. However, I do not know what my constant is because when I differentiate a constant, it goes to 0. Hence, when we're writing an antiderivative, we state that the antiderivative of your function equals 1/3 x to the power of 3 plus c, the constant that you may have had but cannot calculate because when you find the differential of a constant, it goes to 0. Three antiderivatives of x squared could be 1/3 x to the power of 3 plus 5, 1/3 x to the power of 3 minus 2 pi, 1/3 x to the power of 3 plus 0. The general form of an antiderivative is called an indefinite integral, i.e. 1/3 x to the power of 3 plus c is an indefinite integral. This means that we do not know what c the constant is, but we assume that when we're given the slope, or the derivative, and we work backwards to find the function, that there may have been a constant value that I do not know. The following expression reads, integrate your function with respect to x. This is the same thing as saying, find all of the antiderivatives of your function f of x. This is our integral sign. F of x is what we're finding the antiderivative of, and the x is what we are integrating with respect to. Let's look at a few examples of finding the antiderivative. Question 1 states, differentiate f of x is equal to x to the power of 5. This gives us our derivative as 5x to the power of 4. In question 2, we're asked to find the antiderivative of 5x to the power of 4. Here, we're working backwards to find our function, i.e. we are given the slope, the derivative, and we want to find the original function f of x. If g of x is equal to 5x to the power of 4, the antiderivative of g of x is equal to x to the power of 5 plus c. In maths terms, this reads, the integral of 5x to the power of 4 dx equals x to the power of 5 plus c. Let's try another one. Find the derivative of e to the power of x. The derivative of e to the power of x equals e to the power of x. Now, let's find the antiderivative of e to the power of x. The antiderivative of this function also reads e to the power of x plus c, some constant that I do not know. As a math sentence, this reads, the integral of e to the power of x dx is equal to e to the power of x plus c. Let's try another one. Find the derivative of h of x equals pi x to the power of 4. This gives us h prime x as 4x to the power of 3. We're now asked to find the antiderivative. This means you are given the derivative and you're working back to find your function. If your derivative is 4x to the power of 3, then the antiderivative must be pi x to the power of 4 plus c. In maths terms, this reads, the integral of 4x to the power of 3 dx equals pi x to the power of 4 plus c. Let's try a few more examples. Differentiate ln of x plus 2. The differential of this is 1 over x plus 2. We're now asked to find the antiderivative of this function, 1 over x plus 2. Here, we are given the differential and we're working backwards to find the function. This means that g of x equals ln x plus 2 plus c. In math sentence, this reads, the integral of 1 over x plus 2 dx gives ln of x plus 2 plus c. Let's try another one. Find the derivative of e to the power of x to the power of 3. Our derivative becomes 3x squared plus e to the power of x to the power of 3. We now want to find the antiderivative. Here we're working backwards. We are given the derivative and we are undoing this process to find the function. Our antiderivative becomes e to the power of x to the power of 3 plus c. As a math sentence, this reads, the integral of 3x squared plus e to the power of x to the power of 3 dx equals e to the power of x to the power of 3 plus c. An antiderivative is the process of undoing the differentiation. The derivatives and the antiderivatives are given in your formula booklets on page 25 and 26.